So by taking LCM, this is what the equation I got. Z naught is equal to Z naught by delta x plus Z by 2y. Z naught Z delta x divided by 2. 2 to the 4 Z square delta x square plus delta x cancelled, Z divided by 2y divided by denominator. So again, by doing cross multiplication, this into this Z naught square plus z naught by 2 delta x plus Z naught divided by y delta x is equal to Z naught divided by y delta x numerator plus Z divided by 2y plus z naught delta x divided by 2 plus z square by 4 delta x square plus z divided by 2y z naught delta x by 2 LHS z naught delta x by 2 RHS. So these two gets cancelled. Z naught divided by y delta x in LHS, again z naught divided by y delta x in RHS. So these two gets cancelled. So z naught square, there is z naught square in LHS side. Z naught square is equal to z divided by 2y, z divided by 2y, z divided by 2y. There is a mistake, I think. Just a minute. Delta x cancelled, z divided by 2y. Here z divided by 2y. Here also z divided by 2y. So 2y is the LCM, 2z. So that is z divided by 2y plus z divided by 2y. 2y is the LCM. So 2z by 2y, 2 gets cancelled. We will get only z by y. So z naught square is equal to z by y plus z square by 4 delta x square. So if I take common, z naught square is equal to, say, z by y common. So 1 plus z into z, numerator z square. So y is there. So z y gets cancelled. So 4 delta x square. As we know, we have considered a small differential length delta x. So delta x is very small. So delta x square, that will be very small, because say for example delta x is 0.1, then delta x square is 0.001. So 1 plus very small value is always equivalent to 1. So z square by 2 is equal to z by y, because delta x is a small value. So z naught is equal to square root of z divided by y. So z naught is equal to square root of z divided by y, or z naught is equal to square root of, as we know, z is a series impedance. Z is equal to R plus j omega L, and shunt admittance Y is equal to G plus j omega C. From this we can write Z is equal to R plus j omega L, and shunt admittance Y is equal to G plus j omega C. So this is one of the relationship between primary constants and secondary constant, where primary constants are R, L, C and G, and the secondary constants are Z naught. Okay. From the figure, here you can see, from the figure, IR, from the figure, the sending current IR, here the current is entering into this branch also, as well as this branch. so that you have studied in network. Branch current, let us say branch current, the branch current IR flows through this path as well as this path. Branch current is equal to the main current is IS into the impedance of opposite branch. Impedance of opposite branch is Y delta X. 1 over impedance is 1 over admittance, so 1 divided by Y delta X divided by total impedance. Total impedance is Z0 plus Z by 2 delta X plus 1 over Y delta X. So here the branch current IR is equal to the main current into the impedance of opposite branch divided by total impedance. So IR is equal to IS into 1 by Y delta X divided by Z0 plus Z by 2 delta X plus 1 over Y delta X. Okay. So exponential change in propagation of current through the length of transmission line, and it is denoted by e power p delta x. Exponential change in propagation of current through the length of transmission line. We have considered the length delta x, so e power p delta x is equal to sending current Is divided by receiving current IR. Okay, therefore e power p delta x is equal to Is by IR. So from this relation, Is by IR is equal to, by doing cross multiplication, Is divided by IR is equal to, this goes to numerator, so Is by IR is equal to Z0 plus Z by 2 delta X plus 1 over Y delta X divided by 1 over Y delta X. Okay. So Is by IR is equal to e power p delta X. So e power p delta X is equal to Z0 Y delta X plus Z by 2 Y delta X square, delta X into delta X square plus 1. We know that e power x can be written as 1 plus x square by 2 factorial plus x cube by 3 factorial, so on. Therefore e power p delta x is equal to 1 plus p delta x. Here p delta x is considered as x plus p square delta x square divided by 2 factorial plus so on. So from this equation we can write it as, by substituting this to this equation, 1 plus p delta x plus p square delta x square by 2 factorial plus is equal to RHS. I'll rearrange this equation. 1 plus z0 y delta x plus z y delta x square divided by here, this is z by 2 e power p delta x is written as 2 factorial divided by delta square divided by 2. Okay, so 1 gets cancelled here, so p, if I take delta x common, p plus p square delta x divided by 2 factorial. 2 factorial, so 2 factorial is 2 into 1. Okay. Plus is equal to zy delta x. If I take delta x common in the RHS also, delta x common, then zy by 2 delta x plus z naught y. So delta x cancel. So p plus p square delta x 2 factorial is 2 plus is equal to zy by 2 delta x plus z naught y. Okay, here we have considered of small differential length delta x. For delta x tends to 0, then p is equal to, for delta x tends to 0, this is 0, so p is equal to delta x is 0, so z naught y. So p is equal to, as we know, z naught is equal to square root of z by y. So I will substitute this, z naught is equal to z by y into y. So this we can treat it as square root of z into y. So p is equal to, this is another relation between a primary constant and secondary constant, or p is equal to, z is nothing but series impedance and it is given as r plus j omega l, and shunt admittance is given by g plus j omega c. So this is another relationship between primary constants and secondary constant.